here's an example. Given the function f of x equals negative x cubed plus 2x squared minus x plus 2, perform the first and second derivative test to find each of the following. So here's what I'm going to do. I want you to pause the video, and I want you to see if you can find the first derivative and the second derivative. Don't do anything else, just find both of the derivatives. All right, so hopefully you found the first derivative to be negative 3x squared plus 4x minus 1, and the second derivative is negative 6x plus 4. Okay, we now need to set both of them equal to 0, and we need to solve for x. Now there's a word of caution here. I don't like to factor with negatives. Some people don't mind it, but I don't like my quadratics when they leave with a negative, so I'm going to factor out a negative 1, which leaves me with 3x squared minus 4x plus 1. And then I'm going to factor this into 3x minus 1 and x minus 1. So I get x equals 1/3 and positive 1 as my critical numbers. Okay, oops, I'm off the screen here. I'm going to do the same thing with my second derivative. Negative 6x is equal to negative 4. So x is equal to negative 4 divided by negative 6 is positive 2/3. So x equals 2/3 is a possible point of inflection. Okay, so those are my numbers right there that are going on my number line. Let me go ahead and sketch that number line. Let's go with green for my first derivative. I'm going to put 1/3 and I'm going to put 1. I'm going to use, how about blue for my second derivative? F double prime. 2/3 is right smack dab in the middle of 1/3 and 1. Okay, so let's figure out, I need a number to the left of 1/3, between 1/3 and 1, and to the right of 1 to plug into the first derivative. So how about we go f prime of 0, f prime of 2/3, and f prime of 2. Those three numbers fit into those three intervals. So f prime of 0, I'm going to go up here and remember, whoops, I'm going to use my factored form here. Don't forget we have that negative. If you divide that negative out, you got to leave that there, so that affects the sign. So if I put 0 in there, 3 times 0 minus 1, that's negative. 0 minus 1, that's negative. So I have a negative times a negative times a negative, which is a negative. So I have negative signs there. 2/3. If I put 2/3 in here, that gives me 2 minus 1, which is positive. 2/3 minus 1 is negative. So a negative times a positive times a negative is a positive. So I'm going to put my plus sign there. And then I'm going to put 2 in there. 6 minus 1 is positive, 2 minus 1 is positive, but I have this negative out here. So a negative times a positive is a negative. Okay? And now I'm going to do the same thing with my second derivative. A number to the right of 2/3 would be 0. And a number to the left of 2/3 would be 0, and a number to the right of 2/3 would be 1. But this time I'm putting them into the second derivative, which is this guy right here. So if I put 0 in there, negative 6 times 0 plus 4, that's positive. So I put plus signs here. And then if I plug 1 in, negative 6 times 1 is negative 6 plus 4, which is a negative number. So I can put a negative number there. And now I can use my number line to analyze and answer all the questions over here to the left. So, see if you can figure out what all of these signs mean, and when you come back, I'll have the answers. Alright, so hopefully you were able to determine that f of x is increasing from 1/3 to 1. That's where our first derivative is positive. F of x is decreasing on negative infinity to 1/3 because of this guy right here, and 1 to infinity because of that guy right there. X equals 1/3 is a minimum. The graph is decreasing and then increasing, which makes this guy a minimum. And then x equals, whoops, not 2/3. That's supposed to be x equals 1. X equals 1 is a max because the graph goes from increasing to decreasing at x equals 1. So this guy's a maximum. F of x is concave down when the second derivative is, concave up when the second derivative is positive. So that's negative infinity to 2/3. It's concave down when the second derivative is negative. That's 2/3 to infinity. And because it changes sign, you can have functions where you have this number, but they both are positive on either side, or they're both negative, which means that this is not a point of inflection. But we're doing nice basic functions right now, so we're going to get some points of inflection. So x equals 2/3 is a point of inflection. Okay, so your assignment is to do the exact same thing for this one problem. F of x equals 2x to the third minus 4x squared plus 2x. Email me if you have any questions.